This lesson is about solving linear equations when the unknown is on both sides. So I've got three examples here. One where we've got positives, one we've got negatives in brackets, and one we've got a fraction involved. Okay, so the first one, we need to get x on its own. And so the first thing we do, there are other ways to do this, but I'm going to go with taking the number of x's that we can from both sides first. So I've got 4x over here and I've got 2 over here. So the maximum I could take if I'm taking the same from both sides is 2. So I'm going to take 2 x's from both sides. It's always good to write down what you're doing as well. So if I take 2x from this side, 4x take 2x gives me 2x, but that plus 3 is still there because that hasn't been affected by subtracting 2 x's. And the right hand side, the 2 x's have been taken away, so I've just got the 8 left. And now it looks like a linear equation with unknowns on just one side. So now we need to get rid of the 3 because we're trying to get the x's on their own. So we're going to take away 3 from both sides. This leaves me with 2x on the left and 5 on the right. So if 2x is equal 5, I now need to divide by 2 because I want to get down to just 1x. That means that x equals 2.5. Okay, now in the centre one I've got to deal with a bracket before I can get at the x's here. So I need to expand or multiply out this bracket. So 3 times x is 3x and 3 times negative 5 is negative 15. And the right hand side hasn't been affected at all, so we're just bringing that down. Okay, now we'll look at the x's. I've got 3 over here and 1 over here, so the most I can take if I'm taking the same would be 1x, so I'm going to take an x off of both sides. So 3x taken x gives me 2x, and the minus 15 hasn't been affected. And on the right hand side I've taken the x away, so I'm just left with the 1. Now I need to get rid of the negative 15. To get rid of a negative you add, so I'm going to add 15 to both sides. That means I have 2x on the left and 16 on the right. Now I need to get down to x, so I'm going to get rid of the 2 by dividing both sides by 2. Whatever you're doing to one side you must do to the other, and therefore x equals 8. Okay, on the third one we've got a divide by 5 here, and I need to deal with that first before I do anything else. So I'm going to multiply it through by 5. That means I'm going to multiply this fraction by 5, the 3 by 5, the x by 5, and also the negative 6 by 5. Everything needs multiplying by 5. So if I multiply this by 5, I'm going to end up with just 2x because it's cancelling out the divide 5. Minus 3 times 5 gives me minus 15. X times 5 gives me 5x. And negative 6 times 5 gives me negative 30. Okay, now looking at what I've got now, I've got 2x's over here and 5x's over here. Now from the last two examples, the number of x's that were left were always on the left, there and there, but they don't have to be, as you can see here, because I've got 2x's on the left and 5x's on the right. So the most I can take away from both sides is 2x. I'm going to take 2x from both sides. That's going to leave me with all the maximum x's on the right. So if I take 2 x's from the left hand side, I have just the negative 15 left. If I take 2 x's from the 5 x's, I get 3 x's, but the minus 30 is still there. Okay, now I need the x's to be on their own, so it's this one that needs to get rid of now. To get rid of a negative we add, so that's add 30 to both sides. Minus 15 add 30 gives me 15, and it's gone from the right hand side, so I'm just left with 3x. Now I want to get down to 1x, so I'm going to divide both sides by 3. That means I get 5 and 3x. That's meant to be a 5. Sorry, it's a bit messy. Let's just tidy that up. Now if you like, you can turn that around. X equals 5.